Poor Ida.
Poor Ida. Well, he told me you guys just bashed him after the session yesterday too. I'm like, dude, it's not that big a deal. Hey, I wanna start with something a little bit maybe more serious and not so mathy. I just want to tell you, I kind of hit a wall this week, and there you go, Lucas. Good, glad you're in. And I'm just trying to kind of battle through it. And I think the reason that I hit a wall, like I've done this type of thing for years. And so it's not that my head has difficulty doing this, but I think I kind of hit a wall of my heart doing this because everybody that I've worked with in the past in this kind of setting chose this and signed up for this. And you guys didn't choose this and you didn't sign up for this. And I think I'm starting to feel a little bit of the collective angst of all of my students, but I feel it in different ways. And I think you guys probably either hide it better or you manage it better. And maybe it's a little bit of both. And maybe I don't think I've probably given you enough leeway or freedom or opportunity, whatever you want to call it, to express some of that. I feel it very intensely from my younger classes because they don't really have many of the tools to deal with this that you have. They also can't really see the end of the road like at least 3 of you can, as in the end of the road could come, frankly, any day. So I want to ask you this, and this is just going to be something I'm just going to do once. Won't make a big deal of this one. This is not the forum for necessarily sharing what sort of struggles you're having. I'd like to ask if you would, though, at some point today, would you just shoot me either an email or a text message and just tell me really how you're doing, what's going on, what you're struggling with, what's really good about this or what's really gotten kind of hard. For those of you that just joined us, we were talking at the beginning about teachers are trying to give you a break this next week as we give ourselves a break. We're required to take a spring break at some point. And that week that we were out of school, you were out of school, we were still working, getting this all set up. So we haven't had a break yet. My break was going to be in California. It's obviously not going to be there now. So my break is just kind of sitting around not doing the schoolwork. But I'd just like to hear from each of you just really how you're doing. What sort of things are on your mind? What's bugging you? I don't think I have answers for everything. And look, if you don't want to talk about it, I understand that. You can just say, I'm fine. I'll see you in a week. And I get it. That's fine too. But I want to tell you that I hear you and I feel you, and I'm really proud of you for how hard you all
Mr. Roberts
responded to this. But I know it's been difficult. And I don't want you to think that I don't respect how hard this is for all of you. Certainly you seniors, you've got a different kind of set of challenges, but we're all sort of grieving the loss of different things in our lives as this process has gone on. And I think you heard last night, this is not going to end anytime soon. I'm not the superintendent of schools for the state of Washington, but I can tell you almost certainly we're not coming back to school. So that's kind of where we're headed right now. And that's rough. And we're still trying to take a college course, trying to do really advanced things. And I know that I'm really good at the head part of this. And sometimes I forget about the heart part of this. And I want you to know that I value your hearts a lot. And if your hearts are hurting or aching, I just want to hear about it, maybe just let you unload some of that burden. So if you would, I would just love it if you could email me or just shoot me a text. Just tell me where you're at. We're not going to solve any problems today, but we are going to have next week off and sort of a break from this pretty intense work we're doing with identities. And I'll talk a little bit before we're done today about what you can do if you want to have something to do next week, but also you can take the week completely off and nothing's going to be an issue. I will tell you this before we get started. We are planning right now on posting third quarter grades on the 15th. That might actually slide a little bit further. That gives everybody a chance to get in any makeup work that you might have. Hashtag Lucas and Damien. And then any other homework that you might want to get in for this week, you can get in. That'll still count towards third quarter grade. And then any extra credit you want to do next week, I'll still throw that on third quarter. Fourth quarter is probably not going to officially start until the following week. So like I think 23rd is what Mr. Goodnight's talking about. But we got a test right in there. So I'll make sure it counts somewhere. And there's going to be options for how you deal with your high school credit for fourth quarter. College credits, these 5 credits, they don't care about quarters or anything, but we will talk a little bit, probably after next week's break, about what your options are going to be for the high school part of this course. And that's where it gets a little bit tricky. And, they may, in the next 2 weeks, Governor Inslee might come out and say something totally different, and we might be in a brand new world. So anyway, okay, enough of that.
Has Central updated you at all on how the final's going to work?
No. I have the final. So the only issue is how it's going to be administered. And when they sent this survey out to me, I want to say it was right about when we left school. They said any additional comments, and I said, what I really like you to do is send me a proctor form so that I can email that out to everybody and then have somebody there in your presence serve as a proctor for your final while you take it. Over 3 hours is what you're going to be given. You don't have to take it a full 3 hours, but that's what I gave you in class. So I would give you that much time. And either they haven't sifted through it yet or they just ignored me, whatever it is. So at this point, I'm looking at my calendar here. I was looking, I think, originally about May 15th for our final, which is going to be about a month from when I come out of this next week's break. We've got basically one entire topic and then half of another, in your book, one entire chapter and then half of another one to cover. And then we'll spend some time reviewing as well. So I'm thinking mid-May. I don't think that's going to be a problem because we're still basically tracking on the same schedule that I had set out quite a while ago. We can probably adjust for a couple of days, but that gives us a little bit of leeway between then and when school's out. And then, frankly, we can decide what we want to do from there. Once the central final is done, we could just be done. Or if you still want something to do, there's plenty of stuff we could still do that's not part of the central course curriculum that we could do. It's really interesting stuff, and I really like it. And it's sort of those things that are considered what you should know moving on to calculus, even though Central doesn't test for it. But who knows what life's going to be like a month from now, right? Think about a month ago. This is April 3rd. Think about March 3rd, how happy everybody was and how different life is and a month later. So I don't try to make too many plans for that. But let's shoot for about mid-May as of what I think the final will be. And what I'll probably do is I'll give you like a 3-day window, and you just pick a time in that window, and you just take it. And I won't push you at all. I just have to send it to me. I think that they'll be okay with that. I'd feel better if I had a proctor form so I could say that there's somebody at least supervising you, and not that you would ever work with anybody on any other test, but possibly this is one that you need to do totally on your own. Sound good? Okay. Anybody else? All right. I thought we'd start off with going over some problems from yesterday. I can read off all the answers if you want, or you can just ask questions about those problems. I'm open. I have the answer book right here. I can just answer certain questions, or I can read all the answers if you want. You tell me what you want. Or are there no questions?
Read the
Answers, please.
Answers?
Yes.
Sure, okay. So we're on page 388, 7 through 12, 15 through 17, 22 through 24, yeah? Okay, number 7, I've got n pi over 3 plus 2 pi n, and 5 pi over 3 plus 2 pi n. Number 8, pi over 2 plus n pi. Pi over 4 plus pi over 2 times n. Now, some of those answers might be written in different notation than you wrote them. So they might have been simplified a little bit. So don't think that if you're different, you're necessarily wrong. You might be wrong, but don't think that if you're different, you're necessarily wrong. It could just be a little bit different. Yeah. Anna, you raising your hand? Okay, all right. Number 9, I have 2 pi over 3 times n. That's multiples of 2 pi over 3. It's a little bit odd, but whatever. Number 10, pi over 2 plus 2 pi n, 7 pi over 6 plus 2 pi n, and 11 pi over 6 plus 2 pi n. 11, I have pi over 2 times n, and 12, I have pi over 4 times n. And I think I'm going to stop there and ask for some questions.
Number 7.
I'm not hearing whoever's talking.
Number 7.
Say one more time, Foster.
7.
Number 7, okay. Let's go on to the next page. We'll come back to half angles. Number 7, sine 2x minus sine x equals 0. Okay. So this is kind of a classic question where we get to apply this double angle identity. So I'm going to take this and turn it into 2. Are we good? I hope so. I'm not hearing real well today, so I hope that's good.
Yeah.
So from here, now I have a common factor. So I factor out sine x. I get 2 cosine x minus 1 equals 0. And now I use the zero product property. I solve sine x equals 0. And 2 cosine x minus 1 equals 0, which is going to become cosine x equals 1/2. So this one here gives me 0, pi, 2 pi, and so on. So this is n times pi. And this is going to give me pi over 3 and 5 pi over 3. So let me clear that up just a little bit. It's going to be plus 2 pi n. How's that?
Good.
Okay. Others from that first section? If not, I'll move on. Yes, you have one, Lucas? No, you're good to go.
Sorry.
Okay. 15 to 17. 15, I've got 3 sine 2x. 16, 1/2 sine 2x. And 17 is 3 cosine 2x. Issues, questions, move on?
I didn't know what to do with 16.
Okay. So for 16, we have sine x. So if you go back, let me go here. If you go back over here to the double angles page, I see, anytime I see sine x, cosine x, I'm thinking sine 2x. I'm thinking of the double angle identity for sine. But let me just highlight this right quick. But I don't here have exactly what I need. I have just that, right? So I need to double what I have to get there. So basically, let me show you this. This is 1/2 of 2 sine x cosine x. Does that work? And then this becomes 1/2 sine 2x. So again, whenever you see sine x cosine x, you should start thinking about this double angle. In fact, we saw it on number 15, right? Number 15 is 6 sine x cosine x, which I can write as 3 times 2. Same kind of idea. End up with 3 sine 2x. So I want to get to this expression. I just have to figure out how I deal with the numbers to make sure I get a 2 sine x cosine x in the problem. Okay? Okay. 22, 24. This is kind of like what I did in class yesterday, I think. 22, I've got negative 24 over 25 for sine. Cosine is 7 over 25. And tangent is negative 24 over 7. 23, this is in the book, of course. Sine is 15 over 17. Cosine is 8 over 17. And tangent is 15 over 8. And then 24, sine is root 3 over 2. Cosine is negative 1/2. And tangent's negative root 3. And again, we have to be careful remembering where the original angle u is to help us understand where possibly 2u could be. So any questions on that one? So am I hearing that this went okay? Dare I say that?
To an extent.
No, I just
To an
need to
extent,
refresh.
okay, I'll take it. I can live with that. Aiden, would you agree with that to an extent?
No, I just needed a refresher. So now I'm good.
Okay, all right. Ivan, was it as bad as I said it was going to be?
I understand the concept. I still need more practice.
Okay, all right. Well, if it's any consolation, it gets worse today. So that's good news, right? Yeah, right. At least A, I'm recording it, and B, you're here, so that's cool. All right, well, let's go ahead then and look at this concept of half angles. And I have, let me just pull this up here again. I have up on the screen that I will show you momentarily here, half angle identities. And the ones on the left-hand side. This is actually surprisingly simple when it comes to the derivation part. The complicated piece is making sure you get the right signs on the right answers. So let me explain that. Usually deriving stuff is really hard, but once you have all the pieces, okay, I just plug the numbers in and off I go. This is going to be tricky because deriving this is actually surprisingly simple, but the result you get afterwards is a little bit complicated.
So the complicated part is getting the right answer.
Yeah, right. So in other words, hold on, just to be clear, the easy part is the part I'm going to do, and the hard part is the part you're going to do. I should have said that. That's a lot more accurate. I should have just said that. I get the easy part, you get the hard part. That's as long as we understand each other, we're good here. Okay. The good news about the half angle identities, and this really is good news, is that they all derive from cosine 2u. They all derive from the double angle for cosine. And you think, well, how is that even possible? Let me show you. I want to go back. I'm going to jump back and forth here, but I want you to go back and look quickly at the three different expressions we have for cosine of a double angle, right there. I'm going to use u, but a is fine. We can use whatever variable we want. I'm going to replace them with something else anyway. And in particular, I'm going to focus on these two, because each one of them, well, one of them leads me to sine, one of them leads me to cosine, is what we're getting at. So let me show you how this works. And I think you might like it. Let's start with cosine of 2u equals, and we'll do the sine one right now. Let's do cosine first, a little bit easier. 2 cosine squared u minus 1. Okay? But now I'm going to get tricky. Remember, the focus here is on half angles. I don't have halves in here at all. But watch what I can do. I'm going to replace this u with x over 2. And that means I replace this u also with x over 2. So what I want you to appreciate is that any angle that you can think of is half of some bigger angle. That seem reasonable? Any angle you can think of is half of some bigger angle. So I'm just simply treating this angle u that we had before as half of x. And the nice thing about this is this 2 and this 2 are going to cancel now. So what does that leave us with? We have cosine x equals 2 cosine squared of x over 2 minus 1. And our goal here is to just solve for cosine of x over 2. So I'm going to add 1 first of all. Let me rewrite this. 2 cosine squared of x over 2 equals, I don't want to write this. I'm going to go 1 plus cosine x. It doesn't matter if cosine x plus 1 or 1 plus cosine x. Okay, am I losing anybody yet? I just replaced u with x over 2, and then I added 1 to both sides. Now I'm going to divide both sides by 2. So I'm going to go over here now, and I've got cosine squared of x over 2 equals 1 plus cosine x all over 2. I hope you see where I'm going now. Now I just take the square root. And that leaves me with cosine of x over 2. So that was my goal. I wanted to get cosine of a half angle. Now, here's the problem. This is where it gets really dicey. Whenever you solve for something by taking a square root, what do you have to include?
Plus or minus.
Yeah, plus or minus. Yep. So 1 plus cosine x over 2. So as I go back, I'll come back to the screen in just a second. But if I come back here, you'll see that indeed our cosine half angle identity has plus or minus in it. And that means that you're going to have to decide where x over 2 lives. You'll be potentially given x. And we'll do these problems. We'll do these. We'll do them after the fact. After I finish sine, we'll do a couple of these. You're going to know where your angle is, but you're going to be starting with a different angle that might be in a different quadrant. And so the cosine of the bigger angle might not correspond perfectly to the cosine of your angle. So you got to be really careful about which quadrant you're in and make sure you don't get those mixed up. So just be aware, plus and minus can be a little bit tricky. All right, let's put a nice fancy box around that, and let's go to sine. To go to sine, I'm back to cosine 2u. And now cosine 2u is 1 minus 2 sine squared u. Right, this is the other version of the double angle for cosine. Well, what am I going to do? Of course, I'm going to go through and I'm going to replace the u's with x over 2. And the 2's will cancel here. So already you should have an idea of where this is going. But what's interesting about this is that we still end up with cosine x. And I want to show you again what that looks like in the final answer. You have your identity sheets in front of you, but you can see the sine half angle identity still is in terms of cosine. That's kind of unusual. We maybe don't expect cosine to be a factor of both of those, but it turns out that it is. Okay, so 1 minus 2 sine squared x over 2. Okay, I'm going to be a little bit fancy here. I'm going to add this to both sides, and I'm going to subtract this from both sides. I'm going to do it all in one step because you're smart and you can handle this. I have 2 sine squared x over 2 equals 1. So I moved that over, made it positive, 1 minus cosine x. Question? Ivan, you just have a seizure or what? Okay. Okay. So now I'm just going to divide by 2. And then, well, I'll just rewrite it. Sine squared x over 2. And now you know what we're going to do. I'll take the square root. We end up with sine of x over 2 equals, again, we have plus and minus here. So plus and minus the square root 1 minus cosine x over 2. Very similar. If you look back, the cosine, oh, where are we? What happened here? Oh, and back to the very beginning. The cosine half angle identity is the square root of 1 plus cosine x over 2, and sine is 1 minus cosine x over 2. Again, if you're in the mode to memorize these, you just memorize them. Or you can always derive them, but you know I'm going to let you use all this. You can use all these identities when it comes to taking your test. So you're going to have them. But I want you to see where they come from. They're not just randomly made up. They really do come from things that we know, which is how identities are supposed to be developed anyway. All right, are we ready for some practice problems before we'll do tangent in a minute? Can we do practice problems first? Okay, cool. Let's do a couple problems. I would like you, here we go. Let's find the sine of 7 pi over 12. Now, I know we've done 7 pi over 12 as addition or subtraction. Did that a couple days ago with a plus b or a minus b. But let's treat this as the sine of 7 pi over 6 over 2. Okay? Now, let's go through some thought on this first before we get too far into this. First thing I want you to think about is where, as in which quadrant, will I find 7 pi over 12? Where am I going to be in 7 pi over 12?
Quadrant 3.
Quadrant 2.
I'm going to go with quadrant 2. 7 pi over 6 is in quadrant 3. Right? This is worth our time here. I know these are terrible lines, but it doesn't really matter. So 7 pi over 6 is about here, right? Just past pi. So 7 pi over 6 is here. 7 pi over 12 is about here, just past 6 pi over 12. So to be clear, this number here is going to be negative. But this number here is going to be positive. So we need to make sure that our answer comes out positive. And this is where you get to pick the plus or minus. By the way, square roots are always positive, right? So if you know your answer is going to be positive and a square root is positive, the only decision you have to make is, am I using the plus or the minus of the square root? Obviously, we're going to use the plus. So, half angle for sine. This equals plus the square root of 1 minus cosine. Remember, if this is the thing that I'm cutting in half, that's the thing I take the cosine of, over 2. Give me a look, Anna, a look of just utter disgust. This is great. This is great stuff. All right. This is the square root of 1 minus, what's cosine 7 pi over 6? Right here.
Square root 3 over
Minus 3 over 2.
Minus root 3 over 2. Oh, have I told you lately that the unit circle is kind of a big deal? You can see why Ivan and Aiden were so fired up about the unit circle. I mean, it's our thing. All right, over 2. So this is the square root of 1 plus root 3 over 2 over 2. So let's just simplify this a little bit. I can make this into 2 over 2. So this is the square root of 2 plus root 3 over 2. When I divide by 2, it's like multiplying by the reciprocal. And it's the square root of 2 plus root 3 over 4. Now, let's try it out a little bit. 2 plus the square root of 3 divided by 4, square root of that, I get 0.966 approximately. You can play this on your calculator if you want. Sine of 7 pi over 12. Oh, it's a thing of beauty. It's just a thing. Look at that. Look at that. Are you okay? Good. Yeah. It works. Trig wins. So this is just another way to deal with unusual angles. But again, in your defense, we've done sine of 7 pi over 12 before with addition and subtraction. So let me give you another one maybe we haven't done before. Let's try cosine of 11 pi over 8. Let's do some pondering here for a second. And this is where I want you to really stretch your brains a little bit. Think for just a second about where 11 pi over 8 lives. It's certainly bigger than 8 pi over 8, right? Which would be right here pi. Is it this far at 3 pi over 2? Three pi over 2 would be 12 pi over 8. So 11 pi over 8 is right about here. which means that the cosine is going to be negative. Negative something. Negative fairly small, but I don't know. So regardless of what we end up working with, we're going to be taking the negative square root. That's what this all comes down to. Okay? So this is going to be the cosine of 11 pi over 4 over 2. And that's our magic number. So we're going to write 1 plus cosine well, again, the square root will be positive. Now, real quick, what is 11 pi over 4? Is that going to be positive or negative? Who knows?
Positive.
Well, it's
Negative.
Negative.
yes. It was one of those two, yes. Would you agree this is 8 pi over 4 here? So 9, 10, 11 is right here. So
Yeah.
this number is going to be negative, but we know this number is also going to be negative. So don't get confused here. I can have negatives under the radical as long as I don't get weird stuff under the radicals. Here we go. Minus the square root of 1 plus cosine 11 pi over 4 is negative root 2 over 2 over 2. 1 minus root 2 over 2 all over 2. You kind of see the pattern emerging now. This is, well, I want to change colors. This is 2 over 2. So we have negative square root of 2 minus the square root of 2 all over 2, then divided by 2 means I multiply by the reciprocal, and it's negative the square root of 2 minus root 2 all over 4. And I want to give you a chance to test it out. 2 minus the square root of 2. You do this too. I think it's important to see this. I never get tired of getting excited about myself here, but I got negative 0.3827. And then cosine 11 pi over 8. Oh, that brings a tear to my eye. It's so beautiful. So I just want to, we have tangent to do still, but I just want to clarify. In a lot of ways, this is just a fair amount of just plugging numbers into a formula. I get that. But A, I want you to understand where that formula comes from. And B, I really want you to appreciate the importance of making this decision right here to put a minus sign in front of the radical. Of understanding what the sign should be for an angle, like in this case, like 11 pi over 8 and the cosine. Before we move on, I want to ask, is there any questions about this? Tangent will be very logical, but the derivation is going to be a little bit more intense. And there's 3 of them. Shall we do tangent? We shall. Sweet. Okay, tangent of a half angle is just the sine of that half angle divided by the cosine of that half angle. Well, that's fun. Now, we got to be really careful here because this is going to be plus or minus square root of 1 minus cosine x over 2, and plus or minus the square root of 1 plus cosine x over 2. Now, I'm gonna ignore the plus or minuses here for a second. We're going to talk about plus or minuses. It's going to be a little bit tricky, and I want you to be really, really careful about where we're going to end up here. But I think, well, let me just see if this works out for you. I think I can factor out a square root of 1 over 2 from both of these and cancel them. Meaning I think I can cancel this and this. do you feel about that algebra, folks? Good? Hey, you discovered the little hand clap. Anna's finding little things to click on. How do you turn that off? Oh, wow. Anna, you're winning today so far. So we have the square root of 1 minus cosine x over square root of 1 plus. And I want you to notice that any combination of pluses and minuses here, we can take care of by just knowing what the sign is going to have to be. So I don't really worry too much about the plus or minuses. That's why I'm ignoring them for now, because I'm not terribly concerned about what they turn out to be, because I'll make it work in the end. All right, so I have the square root of 1 minus cosine x over the square root of 1 plus cosine x. You will notice that that is our first identity for tangent. You'll also notice that when there's the radicals in there, we still maintain the plus or minuses. So again, we're learning that you're going to have to know what the sign of tangent is for whatever quadrant your angle's in. You can just decide if you're going to take the plus or minus of the square root. Okay, that's the easy part. The hard part now happens, but it's actually worthwhile because you end up with a cooler answer than we have right now. I'm not a huge fan of radicals over radicals. And by the way, I know that the sheet I gave you has one big radical. I split it into two. Hope you understand that's legal. I'm going to keep it split into two because what I want to do here is multiply by something that will get rid of the radicals in my denominator particularly. So what if I multiply it by itself? What do you think happens here? Well, on the bottom, the radicals go away, right? And you just get 1 plus cosine x, right? What happens on the top? I end up with the square root of 1 minus cosine x times 1 plus cosine x, which is the square root of 1 minus cosine squared x, which is the square root of sine squared x, which is sine x over 1 plus cosine x. And that is our second one. Now, I don't know if I went the right order. I'm going to find out now if I went in the right order. I think I went in the right order. Look at me go. It doesn't matter what order you go in, but what happens is when you try to rationalize, in this case, the denominator, but try to rationalize the radicals, you end up with another version of this problem, sine a over 1 plus, or sine x over 1 plus cosine x. Okay, so the question is, how do we get the third one? And I hope you know where we're going with that. Let me go into a new page here. The square root of 1 minus cosine x over the square root of 1 plus cosine x. And I'm just going to multiply by 1 minus cosine x over 1. Just to be clear, last time I multiplied by 1 plus cosine x. I multiply 1 minus cosine x. So I'm going to end up with 1 minus cosine x here. And then can you see what's going to happen here? It's the same thing. This will be the square root of 1 minus cosine squared, which is the square root of sine squared, which is sine x. And there's your third identity. So as we go back and look at options for doing half angles on tangent, frankly, that first one is my least desired one. I don't want to deal with those crazy radicals. I actually like the next two. And you'll have to check me on this. I think that the signs take care of themselves here. I haven't tried every single possible angle, but I think that if you use the second or the third identity, that the SIGN of the answer takes care of itself. When in doubt, you can always make sure that the SIGN is correct, positive or negative. But anyway, let's try a quick example, and then I'll wrap it up. We've been going at this for a while, but we're almost done. So let's try this one. This is one we've done as a sum or a difference. Tangent of 5 pi over 12, which will be the tangent of 5 pi over 6 over 2. Do you want a few minutes to try this? I saw a yes nod, and Anna's like, do not give me time to do this. Just force feed me all this. I tell you, I'm going to give you about a minute head start here. You can pick any version you want. You can pick the square roots if you want. You can pick the sign on top, sign on the bottom. Let's figure out what tangent of 5 pi over 12 is in exact radical form. And then when it comes down to it, we can always check our work with the calculator if we need to. We'll try it for just a minute or two, and then I'll start in about a minute. I'll just pick one of the two. I don't know which one it is, but I'll pick one of the two. We'll try it. So I'm writing this just because I'm a little bit nervous about making sure the signs get right. But I think it comes out okay. There's 1 minus. Yay? No. Yes or no?
No, but semi-close.
Did you do it this way?
No.
No, I did the sign on top.
Okay, let me try it over here. Those of you who did the sign on the bottom, did you get this one? Anybody do it this way? So sine 5 pi over 6 over.
Yeah, I got that.
So this is going to be 1/2 over 1 minus root 3 over 2, right? So this is going to be 2 minus, running out of room here, but let me see what we can do here. I'm going to have 1 over 2 minus root 3 all over 2. So I'm dividing by 2 twice here. If I take the bottom multiply by the reciprocal, the 2's are going to cancel. Can you live with that? So it's 1 over 2 minus root 3. And I think that comes out to be the same thing. 2 minus square root 3. 1 over. Perfect. So Anna, did you get that answer?
No, but it doesn't matter if there's radicals on the bottom or square roots on the bottom.
We're kind of over it now. Do you want to make it? Well, we can do it. Don't think I won't. I'll do it. Oh, I will do it. No, watch. It actually works out kind of cool. I got to multiply by the conjugate, right? This number here should look familiar to you. This denominator will come out to be 4 minus, minus 3. So I end up with 2 plus the square root of 3 over 1. So it does come out, but I'm okay with this. If you want to get, that's fine. We're kind of over that now. We're moving to a point where in calculus we like, well, I don't care if it's radical denominator, whatever. How are the rest of you feeling about this? I want to reiterate one more time. I think that the work I did here today was pretty easy. I mean, I just had to, this is a little bit complicated there, but generally I just had to simplify fractions and maybe a little bit of radical stuff. The hard work you have is checking these and making these work. This is hard work right here. Make sure the numbers come out right. And of course, you can't just say, oh, it's minus 0.3827. You got to be able to show that you know what you're talking about. So, okay, that's all I got. So let me just give you a quick rundown of the plan because we're kind of betwixt and between here. This is 5B. Shout out to Jillian who came up with our new numbering scheme. This is going to be the CUDA worksheet that's online, yeah? Double and half. Did I give this to you? May have given this to you.
I don't have it.
I'm sure it's online. But it should be online.
It's not equations and multi-angle theories, is it?
Yeah, maybe it is. Yeah, I think it is. Does it look like there's half angles in there? No. We already did equations. We did equations on part 3. Go back, go and look in there. It should be double or half. I think that's what it's called. I'll pull it up. Hang on. Who's chatting? Aiden. Gosh. We're not going to panic, Aiden. It's not what we're made of here. Let me pull this down.
Equations and multiple angle identities.
Is that what it is?
Yeah. 5B.
What a double half. This is what I want. Oh, wait, you can't see it. Hang on. This is the one I wanted.
No tenemostat.
Well, that's no bueno. Let me see if I got it here. That's weird. Surely I didn't make a mistake.
Mr. Robinson make a mistake. He would
surely,
never.
Surely you all must be mistaken.
Robots never fail.
CUDA double half is right here online.
This code is perfect.
On the line.
Yeah. So can you go here?
Yes.
Okay.
Good.
So maybe I didn't give it to you. I think I only gave you stuff up through the quiz probably. So you probably don't have these. That's fine. We were both right. So just go online for that. And when you pull this up, remember that when you do these problems, all the answers are on the next pages. So all the answers are there, right? We're beyond the point of I have to check, see if you got them right or wrong. You got all the answers there. Okay?
What if I just write the answers?
That would be a delight. You would get them all right. And everybody would be like, Foster got them all right. No way. That's so cool.
All in my head.
Yeah. Yeah. Where's your work? It's all right. It's all right here.
Internal computing unit.
If you're a freshman, you say, I just did it on my calculator. That's the freshman thing to I just did it on my calculator. Oh,
And they're done.
I am my
graphic
calculator.
So, all right, let's ponder this for a second. This is going to be it for this week. Then we have break. And have you seen what the break's going to look like? Whatever you can do for break, I'll show you. That was a rhetorical question.
Yes.
For break, I have set out for you these 5 problem-solving pages from each of the chapters we've done in the book, including chapter 5.
Can you like change the theme of the background?
No, I like it a whole super lot.
Like,
I can change.
I think it looks amazing, you know?
Isn't it? Thank you, Damien. Thanks for that little respect.
Well, just kind of reminds me of like pre-K on IXL, you know?
Well, pre-calculus, pre-K, it's close.
why did we
I'm
get
going to tell you a
Joku?
story. All right, you ready for this? When I go back to all my classes, let me show you. All my classes have a theme, literally an Algebra 1 theme, geometry theme, physical science theme, but pre-calculus does not. So look at how cool is this? This algebra.
Whoa.
That's my sister's, and I like that one.
But I can't. It's not algebra. Here's geometry.
That looks like Geometry Dash.
Right? Super cool. Physical science. We're studying chemistry right now.
Explosions. Oh.
Like I don't pick the thing, but that's pretty cool, right?
Was your
And of all the ones we looked at, this was
All we have is animals.
what we had was.
This makes us look like.
That's like,
dumb.
It might be
Do you find this offensive? I will change it if you find this offensive.
I mean, it's kind of calming. The monkey's a little funky though.
All right, I will change to a new. I will find a new theme.
No,
I'll add
just
it to
find
my
a
list.
photorealistic of all the animals.
just put a picture of yourself.
Yeah, take a picture of yourself.
I can't do that. There's only come with these fixed ones. I'll show you. You want to watch me?
Stretched out.
Yeah,
All
We
right.
need to have a vote.
choose as a class.
I got to figure out how to do this here. I don't remember how to do this.
All the
Oh, config. Hang on. Config. Hang on. Select a theme. Here we go. So we got Safari Land. I know it's not real big. I could do Art Doodle. I know it's really small, but I can't make it any bigger.
Control
Beach.
Language Arts.
What's beach?
Beach.
That one.
I like that one.
Basic
What's
math.
Astronomy Galaxy?
Beach.
Basic math.
Whoa.
Is that cool? I can change it. I mean, there's lots of them. Look. You want
Whoa.
4th of July? Done.
Wait, what's at the very bottom?
Graduation on lumber. Just to be clear, I spent a good hour to 2 hours
Modern
of my life going through all
DNA.
these.
Modern DNA.
What's
What
high
is that,
school?
modern DNA? Sure.
High
Double
school.
it. I don't know. You want football? Great. I got football.
There's a TP one.
Ivan, look, it's you.
Whoa.
Roman Empire. Great.
Sounds lame.
What's dark
Roman?
green?
No, man.
What's Dark Reef? Where are you?
Green. It was down there.
Oh, dark green?
Just dark.
It's literally dark green.
What's high school A? It's down.
High school A. Where is that? There it is. High school A. Oh, didn't like that one. Feathers? I'll give you feathers.
High school doesn't exist right now.
Oh, that's right. I had to take it off because
Memorial Day.
physical education.
Astronomy.
Astronomy 2.
Astronomy 2.
Beach.
Wait,
It's
generic
kids looking at stars. You tell me what you want. I'll put it on there. Algebra?
Each.
That's lame. Journalism?
Oh god.
Statistics. Ooh, I do like statistics.
Valentine's Day.
Valentine's Day, you got
Wait,
it.
I might do Martin Luther King.
Martin Luther King.
There we go.
That one.
That was
That
the
one?
best.
Okay, done.
Is there a Hitler one?
No, jeez.
Stop it. Okay, there you
Hey.
go.
Yes.
You guys are so weird.
It's
Jesus.
perfect.
All right.
So
It says we have
inspiring.
a dream. It'll push us, you know?
Yeah, all right, motivation. All right,
I'm
so
inspired.
now that you're all distracted by that, let's go back. After break, we'll come back. 5.5C is going to be a lesson on 4.13. 5.5D, also a lesson on 4.14. Both of those at 11:30.
Kiss.
5.5E is going to be a review of all of this. So you may actually redo some problems that you did earlier on. I don't care. Then 16 is going to be a review. And then your test is going to be due 4/20, dude. The 20th.
Why is that funny?
I saw a video of a teacher assigning a test on 420 and someone said they didn't want to do it on such a religious day.
So the review starts on, that'll be like Thursday the 16th, but you have Thursday, Friday, Saturday, Sunday. Test will be due Monday. And I'll have it up there, then you can start whenever you want. And then we'll start on new stuff after that, okay? So this will be in the slides. I don't mean it, this is not super clean, but that'll be our plan. And then we'll do one big unit end of April, 1st of May, and then a shorter unit, probably wrap up somewhere middle of May. Okay?
Ivan, what is that?
My giant pencil.
Oh my
Ivan, what the heck? How have you not been using that in class this year?
It's
He gets more
broken.
work done.
How do you sharpen it?
I don't know. Knife.
You have to carve
An
it?
axe.
Axe.
Chainsaw.
All right, well, you got a lot of time now, so. All right, guys. Again, if you would, I would love it if you would shoot me a text, shoot me an email. Just all kidding aside, out of way of the public, just tell me how you're doing. I worry about you a little bit on a lot of levels. I just want to make sure that what I'm doing for you is okay, that what we're doing for you is okay, and that you guys are okay, because everybody is important in their own way, but you guys are our best and brightest, and I just can't lose you. So I want to make sure you're okay. I want to make sure you're okay. So I won't be doing teaching next week, but I'll be around. You can text me and call me if you get sad. You can tell me to change the theme, and I'll change the theme to something else. But for now, I like it where Dr. King is. I guess it's a great place. That's it.
Can we all come over?
Yeah, but I can't come in because we can't be near each other. We all park in the driveway and stand and stare at each other.
They don't need to know.
This isn't what Dr. King fought for.
Yeah.
This is what we have freedom. He had a dream, so I could come and hang out.
What did he have a doctorate in?
Himself.
What do you have a
Preacher.
doctorate in? I think he had a doctorate in religion, I would guess.
Yeah.
He was an ordained minister. I think he was probably a doctor in religion. But I don't know. I'm not the boss of Dr. King. Anyway.
We could all just stand in a 6-foot octagon, so that we're all.
There's 8 of us. Because there's 8 of us.
Yeah.
Yeah.
That would be
Like
something.
fun.
We get somebody to like sit on the roof or fly a drone overhead and get to take a picture of us.
I got the drone. I got the drone.
Drone?
They thought they were playing a
Now we're getting somewhere, Lucas. Now we're making plans. I like it.